Hello students, and welcome to the course Urban Rail Transit Tracks, Stations and Yards. In this lesson, we explore the various methods for naming the positions of the switch rails in a turnout and delving into the manual operation of turnouts. In a turnout, when the switch rails are set on the straight road, they are set to be in a normal position, and when they are set for the diversion road, they are in the reverse position. When the switch rails are set in a normal position, trains follow an obstructed direct path along the main line with no need for diversions. This alignment is a default choice for the majority of trains passing through the junction or turnout, simplifying operations. Safety is paramount in the railway operations, and the normal position contributes significantly to this aspect. By guiding trains along the primary track without deviations when not needed, it minimizes the risk of accidents or disruptions. The normal position is often complemented by specific signals or switch alignments, providing clear visual cues for train operators. This clarity helps maintain order and efficiency in the rail network. In case where the junction is not actively set for the diversion route, the points naturally remain the normal position, serving as a default configuration. Conversely, the reverse position of the turnout serves a different purpose, directing trains onto the less commonly used direction, often leading to the alternative track. Here's an in-depth look at the reverse position. The reverse position diverges from the norm, aligning points to route the trains onto tracks that deviate from the main line, creating a separation in their path. This position comes into play when the train needs to access an alternative route, such as a siding or a different track, offering flexibility in the railway operations. Switching to the reverse position is typically a controlled and deliberate action, either executed by railway personnel or through automated signaling systems. Safety remains a paramount concern when using a reverse position. Proper signaling, interlocking mechanism, and communication with train operators are essential to ensure the trains are directed correctly in this configuration. The points themselves are designed to align the trains well with the selected diversion track in the reverse position, ensuring smooth transitions. The reverse position finds applications in various railway scenarios, including sidings, crossovers, and access to yards, when trains must access tracks other than the main line. In summary, normal and reverse position are integral to guide trains safely along their routes in railway operations. The normal position streamlines mainline travel, while the reverse position allows for controlled diversions when necessary. Both positions are essential for maintaining the safety, efficiency, and adaptability of the railway networks. The normal and reverse terminology dates from the days of the mechanical lever signal boxes, when the lever was said to be in a normal position when it had not been pulled, and in a reverse position when it had been pulled. Nowadays, signal technologies are improved, but the terms are still used around the world. Meanwhile, other various terms are also used to describe the position of points. Alternative terminologies for normal and reverse, which are used in other parts of the world, include left and right, positive and negative, and direct and diverted. The picture shows how an observer can use the switch points to tell which direction the switch will direct the equipment for the facing movement. To identify the direction in which the switch will direct the train, the observer looks for the gap between the switch points and the stock rail. We can see stock rail are outside the closure rail against which the switch points touch when in the closed position. In the left-hand illustration, the gap on the left side between the switch points and the stock rail indicates that the movement will continue on the left, and in that case, the position of the turnout usually called normal or left. In the right-hand case, the gap on the right side between the switch point and the stock rail indicates the movement will diverge to the right, and that is generally called reverse or right. As what is mentioned before, turnouts are utilized to adjust the position of the railway tracks, allowing trains to follow different routes. And early railway turnouts were operated by pointmen. Due to its low efficiency and safety issues, this way of turnout operation was gradually replaced by signal controller using signal panel or computer in a signal control room to have turnout remote control. By doing this, a turnout on site is handled and locked by point machine. Perhaps you think that turnout manual operation would be an obsolete way controlling switches, but that plays a crucial role in the railway operation if the emergencies such as power outage and signal failures or for maintenance purposes. And that's why there is usually also some sort of manual handle to operate the switch. The manual operation process necessitates strict adherence to a specific set of procedures to guarantee the safety and efficient flow of train traffic. Firstly, you need to identify the specific turnout you need to operate. Then, before conducting any operation, it is essential to ensure that you have obtained the necessary legal permits and permissions to operate the turnout. Additionally, wearing appropriate personal protective equipment such as safety shoes and high visibility vest is essential to ensure the safety of the operating personnel. Moreover, before you begin the manual operation of turnout, ensure that signal protection is applied in the area to prevent any trains from accidentally entering that part of the tracks. The manual operation of the turnout can be divided into 6 steps and summarized in the out chassis, which stands for observing, unlocking, turning, checking, securing, and reporting. Now let's take a closer look at each step in the process of the manually operating a turnout. Step 1. Observing a turnout. Check that the current position of the turnout is correct, and ensure that there are no objects or obstacles obstructing the movement of the turnout. Check for the presence of the locking mechanism. Step 2. Unlocking the point machine. If there is a locking mechanism in place, make sure to remove it. After disconnecting the turnout machine power, open the access cover of the turnout machine. This cover is a protection lid that covers the hole by which authorized personnel can insert hand crank to manually operate the turnout. Step 3. Turning crank to switch. Insert the hand crank into the hole behind the cover and manually turn the lever clockwise and counterclockwise until you hear a clear and crisp sound which indicates that the turnout has been switched to the correct position. Step 4. Checking the position. Confirm with your colleague whether the turnout is in the correct position. Make sure that the turnout complies with the requirements for the train's route and ensure that the correct switch toe and the stock rail are in a close contact as possible. It's critical to know that the distance between the tip of the toe and the stock rail should not be over 2 mm. Step 5. Securing the switch. Use the locking device to manually secure the turnout in a correct position to prevent it from unexpectedly changing positions due to other factors which could lead to a road conflict. Step 6. Reporting. Once you have safely moved away from the turnout to safe area, report the turnout's open position, route readiness, removal of guards, personnel, and clearance of the track to the station control center. When conditions are met, train can proceed with signal. By following these steps, railway personnel can safely and efficiently operate turnouts, ensuring the seamless movement of the trains on the railway network. The manual operations of a turnout is a critical part of the railroad operations and plays a crucial role in directing trains to their intended destinations. Alright, this time we learned how to identify the specific position that a set of a switch rail is in. Based on that, we further delve into the finer details of the turnout's manual operation process. These are crucial for ensuring safe and efficient railway operations. Okay, see you next time.